Hello everyone, I am Francisco Javier Montáns. I am a full professor at the Universidad Politécnica de Madrid. This short presentation is a report on the activities performed during my secondment that I did from Universidad Politécnica de Madrid in Spain to University of Florida in the United States. The secondment took place split in several trips during the years 2023 and 2024. It was split due to the different duties I have to also perform at Universidad Politécnica de Madrid. Well, the secondment has been funded by the H2020 Marie-Sloss Curie Research and Innovation Staff Exchange, or RISE, project with the acronym COMETAS under the grant agreement 101007815. The overall purpose of the secondment has been first to establish a framework of continuous collaboration in different areas between Universidad Politécnica de Madrid and University of Florida. However, in particular, this collaboration was to be made in research in components made of functionally created metamaterials. This has been the topic of COMETAS project, which purpose is mainly performing training and secondments in this topic between academy and industry, both in Europe and the United States. The tasks performed are briefly summarized in this slide. All work has been performed in the framework of a memorandum of understanding that has been established between Universidad Politécnica de Madrid and the University of Florida in the United States. The purpose of the memorandum of understanding has been to establish a framework of cooperation, while at the University of Florida I've been involved in different training activities as conferences and one design course. Simultaneously, we have been advanced in the techniques for developing surrogate models for polymer and metal metamaterials and for progressing in the deployment of the progressive cells along the component. We have also pursued novel applications of the technology as how to control the design the propagation of fracture in components by designing the metamaterial topologies. We have also applied for collaborative research projects in this topic. In the end, we have established a stable collaboration that was the purpose of the experiment. To understand the pursued idea, we have to visualize a functionally graded metamaterial as a continuum with varied properties. If we develop a surrogate model that, by inverse analysis, facilitates the design of the metamaterial, we first must guarantee that all the energies are fully equivalent under loading. That is, the stored or elastic energy, the dissipated plastic energy, and the release of damage and fracture energy are equal in both cases, under any type of loading. Then, for example, if we want to control the propagation of fracture, we focus on a general continuum model, which properties we will be able to design at will by tuning the topology of the metamaterials at every location. Then it has been demonstrated numerically and experimentally that local anisotropy of the material controls the local direction of propagation of the crack. On the left are examples from the literature that have been performed with finite elements and phase field models, with a phase field formulation. There it is shown that changing the principal directions of the material, then we can control the propagation of the crack. Additionally, as we saw on the right of the slide, it has also been demonstrated that under certain anisotropic conditions, we can create, with the design of the metamaterial cell, we can create forbidden propagation directions. That is, we can guarantee that on those design directions, the crack will never propagate. Of course, the idea is to take advantage of this feature. Well, indeed, the idea is to translate this to the design of the propagation path of cracks and the design of the fracture energy along that path. This can be done by designing the topology of the metamaterial cells that constitute the local material of the component at every location. Of course, the applications are enormous, like shielding defense, structural safety, pyrotechnical actuators, etc. Okay, thank you very much for your attention, and if you want to know more about this project, you can visit the web page, and you can also see the publication that we have been performing. Thank you very much.